Hey mathematicians, so today we're going to move into linear inequalities. So now our inequalities got not just have an x, but they'll have an x and a y. So we're going to graph them on a coordinate plane. Now linear inequalities start with a graph of a linear function. So instead of the inequality sign, you can just pretend that it's y equals mx plus b, or standard form a times x plus b times y equals c. So again, remember that we need 2 points to graph that. So once we graph our 2 points, then we got to stop and make a couple decisions. You need to decide if the boundary line is part of the solution set. So these are your vocab words. Boundary line is the line that you would draw. The solution set is all the values of x and y that make the inequality true. So if we see just a greater than or less than sign, we're going to have a dashed line because that line is not included. If we plug in the coordinates that are exactly on the line, they don't make it true, right? If I plug in 2, 0 in this inequality, 0 is not greater than 0. It is equal to it, so it's not included. If the inequality sign is less than or equal to or greater than or equal to, then the boundary line is solid because it's included. Then we just have to decide, after we draw our solid or dotted line, to shade above it or below it. If it's in slope-intercept form, it's easy. If it's a less than sign, you shade below. Just look at the y-axis, go to the y-intercept and shade down. If the greater than sign and slope-intercept, you shade above. Sometimes when it's in standard form though, even though this says greater than, you see that it's shaded below. So we're going to have to test this when we get to that. So we're going to start off graphing the boundary line. So just like normal, just like as if it was a linear function, the slope is -2/3 in this case. And the y-intercept is 3, +3. So first graph the y-intercept, then use the slope to find the next point. So 2 down and 3 to the right. 2 down, 3 to the right, there's our other coordinate. Okay, so now we just need to look at the inequality sign and make a decision. Is the boundary line solid or dotted? Since this is only greater than, we know it's a dotted line. So dot, 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 dot. And there's this dotted line. Do we shade above it or below? So since it's in slope-intercept, it's easy. We just look at it, it's a greater than sign. So we know we're shading above it. So all these points up here in the half plane above the boundary line make the inequality true. And you can take a look. So if I tried 0, 3, so x is 0, y is 3, -2/3 times 0 is 0, and 3 is not greater than 3. So that's why that is not included on the boundary line. But if I plug in 0, 4, say right here, 4 is greater than 3. So anything in this shaded area makes this inequality true. That's why it's part of the solution set. So a little trickier is the standard form. So even though this is a greater than or equal to sign, we can't be guaranteed because of positive and negatives that it's going to be shaded above. So we're going to have to use a test point. First part's the same. Find the x-intercept and the y-intercept. So 2x equals 6. So divide by 2. So we know our x-intercept is 3. Same thing with y-intercept. We just want -3y equals 6. So divide by -3. And y-intercept is -2. So we look at our inequality sign for our boundary line. So now we have 2 points. We draw a line through it. We only want to know, do we draw a solid or dotted line? Since this is greater than or equal to, we draw a solid line. Relatively straight. Okay. Mathematicians are lazy. So when we pick a test point, generally we pick 0, 0. Because that makes everything on the left-hand side here 0. So we want to put, is 0 greater than or equal to 6? No, it is not. It is less. So 0, 0 here is not shaded, so we shade the other side. So we shade below. Even though it says greater than or equal to sign, the test point at the origin is false, so it's not shaded, so we shade below it. Okay, so just when you have standard form, make sure you use the test point at the origin, and if it's true, you shade the origin. If it's false, you shade away from it.